So what have we learned about associations? And like I said, this is a topic that probably 90% of the time you spend doing model logic, you're going to be dealing with associations. So as usual for this course, there's so much material about it that we've tried to give you an overview of the most important concepts. You'll find yourself consulting the documentation and the readmes and example code a lot. But what have we sort of seen? The idea of associations is really something that comes from your application architecture, right? You have a set of different models or classes, and they have relationships among each other. That's what associations are trying to help you model. So the association support in Active Record provides a high-level way to manage them that kind of makes it look like you're really managing an object graph, even though what you're really doing is managing these relationships in a database. And because of the modules mechanism, right, the idea that I have a set of behaviors around a table with a foreign key, and I can construct queries that use that foreign key as an index to another table. All of that stuff is implemented basically as a big module. The module gets mixed into Active Record, and that's why you can use it in all these different models. The things that are, when you say movie.reviews and somebody asks a question, well, what is movie.reviews? Is it an array? Is it? No, this is a perfect example of saying, don't worry about what it is, worry about what it responds to. What does it quack like? It quacks like an enumerable. Does that mean that as soon as I have it, I can enumerate its elements? No, it just means that if you try to enumerate its elements, the right thing will happen. And as we've seen, a very powerful part of what that lets you hide is that the query doesn't happen until the last possible moment. So it's actually a really nice example of a language technique, right? The combination of lazy evaluation and higher order functions actually combining to giving you something that when you program with it, you can more or less treat it like it was just an array, knowing that at runtime it will not behave naively. It'll actually behave nearly optimally, I guess, if you want. So the things that actually get returned from movie.reviews, we call it a proxy object because its job is to essentially figure out if this was the real object, if it was really a collection of movies, what could it do? Well, it could respond to each. So if I'm called with each, I will do the thing that's necessary to essentially play my role, to be the imposter. I will cause the query to happen and then start yielding the results one at a time, because that's what each would do if I was just a normal, honest-to-goodness, enumerable collection, if the query had been done non-lazily. We also saw the idea that nested routes are provided as a way to help you define what the RESTful names for these things are and to easily construct forms and URIs that name them, just like we did with the simple models. And all of this really rests on the fact that relational databases happen to provide a nice way through the use of foreign keys and joins, which are sort of, that's kind of the bread and butter of databases, right, is doing joins. This is a thing relational databases have been engineered for decades to do well. So the associations module really is building on sort of decades of database engineering that allow us to do this. And if you remember, one of the things we talked about earlier in the course was the idea that in this three-tier architecture, when you get to the database tier, scaling becomes more difficult. And as a result of that, people have started doing NoSQL and MongoDB and Couch and all these other databases that lack a lot of the power that full relational databases have in them. Well, this is a really good example of it, right? The reason associations work as nicely as they do in Rails is because most of the work is really being done already in the database. So if you were doing an application that couldn't take advantage of a relational database because, for example, some aspect of the scale is just way too large, you could use a pattern like DataMapper, which we recently introduced, which means that you would have to write your own traversal methods if you wanted to express associations. It's not to say that you couldn't do them. It's just that the database doesn't already build in a lot of the support for doing joins, so you would end up essentially writing join code in your application. So, and this is actually a big pitfall of what people who start out writing their apps against a NoSQL database, they immediately run into it, right? Is that what they find is that the first couple of models are easy, but as soon as they have to implement associations, they essentially end up writing code in their apps that duplicates what a relational database would have done in the database. So does that mean there's always a bad idea to use DataMapper and to use a separate database that doesn't have these features? No, sometimes you have to do that. But you should understand what it is you're giving up by making that choice, right? The relational databases can get pretty big before they're no longer tenable as a single honkin' database. And in fact, a lot of you are now using Pivotal Tracker. You started tracker projects for your group project. All of Pivotal Tracker lives in one relational database, right, for the entire world. So think carefully about, I'm going to use a NoSQL database. Well, OK, but the downside of that is NoSQL, right? There's a lot of useful features that you get. One question that came up earlier, or I guess somebody made a comment that suggested the question, is the idea of referential integrity, which is basically what constraints do we want to have if we have a movie that owns some reviews and we delete that movie? What's the right thing? What should happen? And the question of what the right thing is really is about your application. But what happened in the database is that you'd now have a bunch of reviews whose movies ID field, foreign key, now refers to a non-existent record. And by the way, this is another reason that primary keys are never recycled. Most databases assign only unique primary keys in each table. You can imagine the chaos if a particular movie ID used to point to some movie, and then that primary key got recycled, and now the same number points to a totally different movie. That'd be terrible. So depending on what you decide to do, there's various ways when you set up your association that you can direct Rails, here's what to do when the owning object is destroyed. I can say dependent destroy, which means when the owning object is destroyed, all of the owned objects get destroyed along with it. I could say dependent nullify, which means when the owned object is destroyed, any foreign keys pointing to that object are set to nil. Now, that assumes that in your schema or in your application architecture, it's meaningful to have keys that are set to nil, right? In our simple example with reviews, I don't think it makes sense for a review to exist independently of a movie. But you can imagine, for example, a site where you've got some sort of an asset, like a picture or something like that, in some cases may have an owner, and in some cases may have no associated owner. Or that you don't want to, imagine a blogging site where you always want to keep the posts around, even if the original authors who made those posts decide to unsubscribe. Maybe there's a case for saying, OK, some blog posts don't really have an owning author. So depending on what makes sense for your app, you can do either of those things. And we also showed how when you're managing models, there's these places in the life cycle where you can insert your own callbacks. You can do customized things. You can imagine putting a customized callback so that when you destroy an owning object, you can actually get called for each owned object. You can make a separate decision on what to do with each one. So all of these things are sort of part of the framework. And by the way, you should always be asking yourself the question, whichever choice I make, how would I test it? So here's an example of how you might test for referential integrity, that it should destroy the reviews when you delete the movie. Well, you could create a movie. You could create one or more reviews for that movie all inside of your test case. You could destroy the movie after remembering the ID of the review. And now you can, inside of a Lambda block to catch the exception, you can make sure that if you try to find that review ID, that it isn't found. So again, this particular case, really what you're doing is testing stuff that is in Rails already. But I just wanted to point out that, as a general rule, whenever you're thinking about what I want to do in my app, you should at the same time, like Pavlovian dog, think about, what am I going to do to test this functionality? Things that we're not going to talk about in this lecture, but it's depending on what your app does, you may have a need for them. Single table inheritance is a way to collect a group of similar models under a single table so that they all subclass from the same thing. There's a lot of shortcuts that become very easy if you do that. Self-referential has many through. This is worth looking up. Basically, the question here is, if you're talking about relationships from friends to friends, then my association is with another thing that is of the same kind as me. And that's actually meaningful. You can code it, but there's a few caveats you have to keep in mind. And the associations guide, which I recommend as a first pass, has some good examples of that. And just like validations, there's many other declarative options on associations. For example, just like scopes can be used to capture specific queries, I can open some options on associations that say, not only does a movie have many reviews, but a movie has one most recent review, which is really just a version of the has many reviews, but on the criterion of sorting them in reverse order. And you can make that declarative so that you don't have to manually write your own code to figure that stuff out. So associations are your friend. You're going to use them a hell of a lot. Get used to them. Love them. And since we have like 2 minutes, I want to close out with one computer history fun thing. Well, I think it's fun. So today in computer history, technically it's tomorrow in computer history. So October 15th, 1956 is when that manual on the left was published. In case you can't read the small type, it says Fortran for the IBM 704. This was, this was back when the idea that you wrote a piece of software for a computer, that was just the way it happened. It's not like this is Fortran. This is a program that runs on this particular computer. If you'd like Fortran, what you should do is get an IBM 704. That would be an excellent first step. And the book on the right, which I'll bring a physical copy of on Wednesday if I don't forget, is what I believe is the first ever textbook on programming in a higher level language. So 1957 on the left, 1961 on the right. You can get these on eBay for like $100 now. But what's interesting, if you look at the original Fortran manual, which IBM has been kind enough to make available on their website, you notice they call it the automatic coding system. from where you're sitting, I'm thinking having an automatic coding system would be awesome. But to quote a line from a movie that you're too young to remember, I do not think that word means what you think it means. So trying to put yourself into, like, in 1956 when Fortran came out as the first high-level language specifically designed for scientists to get their work done without learning assembly language, right? That's, I mean, yes, you heard that right, right? The idea was when you wrote down the equations you wanted to solve and translating those into assembly language in such a way that you could actually perform the computation on the hardware, that was what people called coding. So if you could just kind of write down your equations in a stylized way and have a compiler generate that for you, that's automatic coding. So the good thing is we've come a long way since then. And the bar for automatic coding just keeps getting higher and higher, right? Whenever somebody gets something done, like, oh, that's not automatic coding. That's just another level of compiler, or that's just code generation, or that's just metaprogramming. So think of all the things that Rails automatically does for you, and just assume that in a few more years, people will take all that for granted. With that, come to the